Hi. My name is Alana, and I am represent Group 2, FD1, for Chemistry 3 Topic 2. Today, we will discuss chemical oxygen demand experiment and its calculation. What is chemical oxygen demand or COD? Chemical oxygen demand is the amount of oxygen needed to oxidize the organic matter present in water, and used to determine the amount of oxidation that will occur and the amount of organic matter in a water sample. Also, used to determine the amount of inorganic chemicals in a sample. Now, let's start the experiment. For this experiment, we need 1 cubic decimeter of sample. Acid sulfuric sufficient H2SO4. Silver nitrate, AgNO3. Potassium permanganate KMNO4. Sodium oxalate. First, add acid sulfuric sufficient to the 1 cubic decimeter of sample in the conical flask, to acidify the sample. Next, we need to add silver nitrate to the acidified sample, to remove the chloride ions. Next, we need to do the titration. So let's prepare our burette. The first step is start by rinsing the burette. Use distilled water to wash the inside of the burette. Release the water from the bottom of the burette so that we wash the tip as well. Pour the rest of the water out from the top of the burette. The second step is to prepare the burette. Rinse the burette with the titrant using a funnel to help you pour the solution into the burette from the top. Make sure the tap is closed at the bottom or you'll have a puddle on the floor. Fill only a third of the burette. And open the tap to wash the tip of the burette just like you did with water. Pour the rest of the solution out from the top of the burette, cleaning all of the inside of the burette as you do so. Now you are ready to fill the burette with the titrant. Pour the titrant in from the top using the funnel. Now you need to release the bubbles from the tip of the burette. Do this by opening the tap all of the way and let the solution push the bubbles out. Let's see this again by slow motion. Watch the bubbles closely as they come out of the burette. Now we are ready to begin. Add 1 cubic decimeter of potassium permanganate to the solution. Next, we need to heat the solution for 30 minutes. After that, we need to add 1 cubic decimeter with the concentration of 0.0125 decimeters per mole 3 of disodium oxalate into the solution and stir the solution well. Oxalate ions that remained unreacted were titrated with the potassium permanganate solution until the solution become pink. Use 0.03 cubic decimeters of the solution. Yay! We are done with the experiment. Now let's proceed to the calculation.
Let us continue with equation of redox for reaction of potassium permanganate and disodium oxalate. We know that incomplete half reaction of this redox equation is firstly MnO4 minus produce Mn2 plus, and C2O4 2 minus produce 2CO2. From the first equation, we have to add 4 water on right side of equation to balance O in equation. Then we add 8H plus to balance H produced from water. Then we add 5 electron to balance charge in equation. For second equation, C and O already in balance, but we need to balance the charge in equation. So we add 2 electron on right side. We have to combine this to equation by multiply with 2 and 5 to first equation and second equation. Then we can cancel out electron because it has same value for each side. Next, we just need to rewrite it because it already in a balanced equation. First, we have to use equation mol equal to mv. Value of m and v is already given in question. The answer is 5 times 10 to the power of -4. Molar mass of O2 is 32 gram per mol. To calculate mass of O2, we have to multiply value of molar mass with mol of O2. Its value is 16 milligram. Value of FAD is 100 milligram per dm³. Next question is reason of removal chloride ion. We move on the next question. Calculation COD of sample solution. First, we need to calculate mol of Na2C2O4. The answer is 1.25 times 10 to the power of -3 mol. Then the excess of Na2C2O4 is 0.75 times 10 to the power of -4. Next, the concentration of COD find using ratio of mol equation. The answer is 2.5 times 10 to the power of -3 mol per dm³. To calculate COD, we have multiply 32 with 2.5 times 10 to the power of -3. The answer is 80 milligram per dm³. Total amount COD of sample is 240 milligram per dm³.